Hey guys, this is the last section in 11 point, or well, in chapter 11, and it is 11.3, solving radical equations. So the good thing is you're going to solve these pretty much the same way you solve any other equation. The bad news is if you don't know how to solve equations, you're going to be in a whole lot of trouble. So hopefully we're going to get this down pretty quickly and it'll be nice and easy for you. Example number 1. On your packet, I believe I did not write any of your examples. Please make sure you are beginning by writing the problem down. Then you're taking good, nice, neat notes. Writing everything down, not just what I write, but sometimes if I say something, you're like, oh, that's important. Please write that down. Okay, so you can see we have an equation, and it has a radical in it, a square root of x. We want to solve this. Well, remember, when you're solving an equation, your goal is the same as it always has been, and that is to isolate x, to get x all by itself. Okay, you want to isolate the x or whatever variable you happen to have. So what you have to do is use opposite operations or inverse operations to undo whatever's being done to your variable. So I see I have a square root and I have a minus 3. When you're undoing the operations, if you remember, you do the opposite of the order of operations. So you would undo any addition and subtraction, then multiplication and division, then exponents, and then parentheses. You may not know this yet. You get more into it in Algebra 2, but a square root, where would that fall? A square root is actually an exponent. Okay? When you have something like the square root of x, that's actually x to the 1/2 power. You may not have ever seen that before, but that is what it is. It's just a fraction in the exponent. That's how you get a radical. Not a huge big deal for us right now, but it is important to know that's where it falls in the order of operations so that when we're undoing it, we know which order to do it, to undo things in first. So if that's the case, in this particular problem, we have the radical, so that would be the exponent piece, and we have a minus 3, so that's the addition subtraction. Which one of those should be undone first? Well, it's the opposite of the order of operations, so you would undo the subtraction. How do you undo minus 3? You need to add 3. So that eliminates here. The square root of x equals 7. Move that together a little more there. And then we need to undo the radical. You need to get the x all by itself. What's the opposite of a square root? Like the opposite of minus 3 is add 3. What's the opposite of a square root? What would undo a square root? A square. Okay, a second power. So whatever you do on one side, do on the other. The square root and the square, those will cancel. So all we have left is x, and 7 squared is 49. Okay, that would be your answer, but of course it's an equation. You should always check solutions on equations. So what is the square root of 49? It's 7. 7 minus 3 is 4, so that answer checks out. We are good to go. Example number 2. Again, please make sure you write down the example. Okay, on this one, if I'm looking at my order of operations, I see that I have some addition, I have some subtraction, and I have a radical, and we know that's really an exponent now. So, you're probably thinking I need to undo addition and subtraction first. And you're partially right. What would be the first one to get rid of? Hopefully you're thinking this plus 2, it's all by itself at the end. So yep, let's subtract 2 on both sides. So then we are left with the square root of x minus 3, and we are now equal to 2. I like my things lined up there. So these are gone. Now, according to order of operations, we have subtraction and an exponent, a radical left. If you're doing the reverse of order of operations, subtraction would be the next thing to undo. However, See how that radical is over the subtraction as well? That means that radical is actually acting as a parenthesis. The radical is saying, hey, I'm taking the radical of all of this. So you've now got to undo the radical before you can undo the subtraction. It's all grouped together. Okay, so once you have the entire radical isolated, then you're going to square both sides. So if I square both sides now, my square root and my square will cancel. I'm left with x minus 3, and I'm now equal to 4. Then you can add the 3 to get x by itself. Okay, so if you've got the square root over more than one thing, like we do in example 2, you need to isolate the square root and then square both sides. And then only after that can you get rid of whatever else